Welcome to Plutus IS. Today we will see example of cyclic group to find the number of single generators in a cyclic group. For example, I will take example find the number of single generators in the group. Example Z10. That is, we have to find the number of single generators, and when we find the number of single generators generally in the case of cyclic group, so we know that Z10 is a cyclic group. And what is the cyclic group? Any group which is generated by a single element is called the cyclic group. For example, Z10 is a cyclic group. We can write all the elements of that, means we can generate the Z10 by a single element. But here problem is that to find the number of single generators in Z10. So in general, Zm is a cyclic group with respect to addition of residue classes. We know that this is a group with respect to addition of residue classes, and this is a cyclic group, finite cyclic group. It's a finite cyclic group, and number of generators in the cyclic group is phi m. That is the result. Number of single generators in single generators here equal to simply phi m. And what is the phi m? We know that the phi m, that Euler phi function. And what is the phi m? That means m is obviously greater than 0 is a positive integer. And what is the phi m? Number of positive integer less than m and co-prime to m. We have already discussed about the what is the phi m. So now simply directly we have to calculate here. Now this is the cyclic group, and we have to find the single generators. How many single generators in this cyclic group? So that is directly we use the result and calculate the phi m. Like in this case, so what will be the number of single generators? Therefore, calculate the simple phi 10, and you know that how to calculate the phi 10. Simply phi 5 into 2 equal to phi 5 into phi 2 equal to 4 into 1 equal to 4. We know that the formula phi m1 into m2 and m1 m2 are co-prime, then that phi is the multiplicative, and you can write directly the phi m1 into phi m2. Here the both are prime numbers p1 and p2, so directly we can write the phi p1 into phi p2, and we know that the formula phi p equal to p minus 1. So directly 5 minus 1, 2 minus 1, that means 4. So there are 4 single generators of this cyclic group Z10. We can see here. We can also check that the single generators. How we know that the what is the Z10? What are the elements of Z10 are 0, 1, 2 up to n bar. These are 10 elements, and all are the residue classes modulo 10. So now we can check that which one are the generators of this cyclic group. And generators, single generators means by that element we can write every element of the group. So now if you check the 1, so 10 can be written as 1. If you add 2 times, then you can get the 2 bar. 3 times, that means 3 times 3, and so on. 9 times 9 bar, and 10 times again 0. So obviously 0 times equal to 0 bar, and 1 times, okay, just write here 1 times equal to 0 and 1 times equal to 1. So again that means 1 is the generator of this group. By with respect to 1 only we can write every element of this group. Now check another one, 3. So the 3. So now 3, 1 times 3, that's the 3. 2 times 3, 2 times 3, 6 bar. 3 times 3 equal to 9 bar. 4 times 3, that means 12, and 12 means 2. 5 times 3 bar means 15, and modulo 10, that means 5. 6 times 3, that means 18, and modulo 10, that means 8. 7 times 3 bar 21, 21 modulo 10 that means 1 bar, 8 times 3 that means 24, and 24 modulo 10 means 4, 9 times 3 27, and 27 modulo 10 is equal to the 7, and 10 times, and the 10 times 3 equal to 30 bar, and 30 bar modulo 3 that means 0 bar. Then we can clearly see that by using the 3 we can write every element 1, 2 bar, 3 bar, 4, 5, 6 and 7, all the elements of this group. All the elements of the group can be written with the help of only 3. That means 3, the element 3 of the group generate the Z10. We can check that the 2 cannot generate the Z10, like if you add the 2 1 time 2, second 4, 6, 8, 5 times 0, again 6 times we will get the 2, and again 7 times 4 and so on. So we cannot write the 2, 1, 3, 9 with the help of 2. So 2 is not the generator of this group. Similarly 4 is not the generator of group, 5 is not the generator. You can check 7 is again the generator, and also similarly 9 is generator of this group. That means, and how to write, if A belongs to G and G is a cyclic group, then we can write like this G. That means G is generated by A. If G is a cyclic group and generated by element A, then we can write in symbol this. So here Z10 is a group and there are 4 generators. That means 1 bar Z10. Also Z10 can be written as 3 bar. Z10 also can be written as 7 bar. Z10 can be written as 9 bar. So in a cyclic group Zm, finite cyclic group Zm, how many generators, how many single generators are phi m. Phi m are actually, phi m gives the number of generators simply, but which are generator we can calculate by like this. So here in this case in Z10, 1, 3, 7, as 1, 3, 7 clearly and 9 are co-prime. What the phi m gives? Phi m gives actually the number of positive integer which are co-prime to m and less than m. So basically in case of, we know the phi 10, we get the 4, but what the 4 numbers are, that means less than 10 and co-prime to 10 are 1, 3, 7 and 9 are the only numbers which are less than 10 and co-prime to 10. That's why 1 bar, 3 bar, 7 bar and 9 bar are the generators of the group Z10, cyclic group Z10. Similarly, if you take another example like the Z6, then which are the generator and how many generators? So how many generators you can calculate directly by using the phi 6. Phi 6 you can calculate the phi 6 with we will get here the phi 2 into 3, that means phi 2 into phi 3, and you will get the 1 and 2, that means 2. There are 2 generators, and Z6 which are the generators, 1 and 5 will be 1 bar and 5 bar actually generators of this group 5 bar, as 1 and 6 are co-prime and 5 and 6 are co-prime. So there are 2 generators, 1 bar and 5 bar of this cyclic group. If you want to calculate the how many generators in a large cyclic group, like if I give the, find the number of generators in a cyclic group Z10, then simply just calculate the 500, and already in a previous lectures, previous videos we have already seen how to calculate the 500. So simply write the prime product of the 100 prime factorization, that means 2 to the power 2 into 5 to the power 2, and that means 5, 2 to the power 2 and 5, 5 to the power 2, that means 2 to the power 2 minus 2 and 5 to the power 2 minus 5, and you will get the 4 to 2, and here 25 and 25 minus 5, that means 20, means 40. So there are 40 single generators of this cyclic group. Zm is always a cyclic group, is a finite cyclic group, and so now we conclude that how many single generators of this cyclic group Zm. Simply calculate the phi m. Which one, if you want to write which one are the generator, then simply take the elements of Zm which are, that means which are co-prime to M. So like simply in case of Z10 3 7 9 1, in case of Z6 only 3 not 3 1 and 5 are co-prime to 6, that means 1 bar and 5 bar are generators of the cyclic group Z6. So we'll talk about the, also to find, we'll check the about the how many generator of the group that means is a group of prime residue classes modulo M. In the upcoming videos we will talk about the how many generators of the group with respect to multiplication. Thank you.